Let's continue our discussion of the normal distribution. We need to define the standard normal probability distribution. This is a special case of the normal, where the mean is equal to 0 and the standard deviation is equal to 1. Shape is exactly the same as in the normal distribution. We can also call this standard normal distribution the z distribution, and it is based on the continuous random variable z. Earlier in Chapter 3, we learned about z-values. We can calculate the z-value for any normal distribution with this formula. For any x, the z-value is the number of standard deviations that x value is away from the mean. The key determining the probability in any interval in a normal distribution with mean and standard deviation is to convert it to the standard normal, or the z distribution. This is best explained with an example. As with all business problems, it's important to read carefully the situation and interpret words to be able to derive quantitative values. This example is a very real situation for any business. Inventory is expensive, and every business wants to minimize that cost of inventory. At the same time, businesses need inventory on the shelf to satisfy and retain customers. In this case, the owner of the store is concerned about having 20 gallons of oil on the shelf. Knowing that we plan to have these 20 gallons in inventory, we want to know the probability that demand will exceed our inventory before we have the chance to replenish. If we could draw our distribution, knowing that area in an interval under the curve is equivalent to the probability, we want to find the area to the right of x is equal to 20 gallons. We do have past data, though, saying that the mean demand is 15 gallons with a standard deviation of 6 gallons. The first step, knowing the mean and standard deviation for our normal distribution, is to calculate the equivalent z-value for our x value of 20. We find that to be 0.83. The second step is, using the z-value of 0.83, we find the area under the standard normal or z distribution curve, which is to the left of z of 0.83. Rather than calculating the probability using a formula, again, we are lucky that statisticians have already calculated the area under the standard normal distribution curve for any z-value. This area is equal to the probability of being less than that z-value. The table described here is in the back of your textbook, and from this we can find that the probability of z being less than 0.83 is 0.7967. But from the original statement of our problem, we know that we want to find the probability of x greater than 20, which is z greater than 0.83. So therefore, we need to subtract the area less than z from 1 to find the area greater than z of 0.83. Therefore, 1 minus 0.7967 is equal to 0.2033. This is described graphically here. And knowing that the z-distribution was converted from our original distribution, we know that the probability of x greater than 20 is the same, 0.2033. We can also work this type of problem in reverse. What if the manager wants to know the number of gallons, or what x value would have no more than 5% or 0.05 probability of occurrence? We can use the standard normal table in reverse. Looking at this diagram, we want the z-value that corresponds to 0.05 probability to the right, which is equivalent to the z-value with 0.95 probability to the left. If you remember looking at the z-distribution table, you are always given the value of the probability to the left of or less than a z-value. We find that the z-value that corresponds to 0.95 probability is a z of 1.645. Working backwards with the formula for the z-value, we know our original mean and standard deviation. We can then calculate the corresponding x value. We round that to 25 gallons. That tells us that a reorder point of 25 gallons would give us approximately 5% or 0.05 probability of having a stock out. One secret to solving any continuous normal distribution problem using the z-distribution is to draw the curve. Mark your mean and standard deviation, mark the x value of interest, and then relate that to the corresponding z-value in the z-distribution. To conclude this example, if we raise the reorder point from 20 gallons to 25 gallons, we reduce the probability of a stock out from 0.20 to 0.05, or from 20% to 5%.